Okay, so this is what I planned for today.
Only focusing that area, not in this one.
No, but right now this is recorded in Zoom, right?
Yeah.
Okay, so when I do this, I will not. Don't worry about it. But you can switch, no? You can switch here, I think. I see no reason why you can't switch. Right? Normally you can switch. Anyway. Yeah, you can switch. Hold on. AB in. Okay, call him. Well, you have really good eyesight. Okay. Okay, anyway. So, yeah. What I want to do to begin this class is just a 5 minutes of review of the course objectives so that I get the continuity going. It's in the syllabus, but it's worth spelling out. Okay. What I want you to do by the end of this class, just bear in mind that this is the learning outcome. You know, this is a sort of like that philosophy of outcome-based education. Okay. The first objective for this class is that by the end of the term, by the end of the semester, you should be able to sort of like put yourself, you know, in the mind of a professional data scientist. You're not professional data scientist, but sort of like, what would a professional data scientist do on a typical day in terms of formulating, you know, looking at the data, assessing the data, what's called data asset, how much information, how much data set, how long a time series, that sort of thing. Munching, playing around with this incomplete, this not available, this repeating name, all kind of stuff, and then formulating some kind of analytics on it, applying the analytics to get some insights, right? And then visualizing all along. Okay, so you do the visualization at the beginning, so you get information, you get insight of what the data looks like. You perform analytics, like maybe machine learning, maybe probability model, maybe some kind of some algorithm, and you get the result. Then you visualize the result. So this whole thing, this long thing, I use the word pipeline, and that's the word we use a lot, because you take one thing and you pipe it to another. It's sort of like a flow of water, okay? But from dirty water to clean water, or from raw data to insights, okay? So that's what I want you guys to do, right? To have this kind of experience. Now, that's not enough. Along the line, you'll be using certain tools, you know, certain classification tools. I want you to understand the basic mathematical foundation, why it works, how it works, for what class of problem does it work. For example, let me just give you a far shot. Let's say on an exam, I can ask you, say, you know, what is the one key feature of a data set that say you can use logistic regression to do classification, or you cannot use logistic regression, you must use something like neural network multi-layer perceptron. What is the one feature of the data set that say logistic regression cannot cut it? Okay, what's the one feature of the data set? So the reason you would be able to make that kind of statement if you understand how logistic regression works versus how neural network works. Okay, now the answer is nonlinear versus linear separability. Okay, but you know, we'll come to that. But it's that sort of thing. Once you understand how the engine works, you're not just willy-nilly putting this to that. Okay. And I made fun of my own staff when I was working professionally. You guys are working like Lego, because a lot of time when they get a data set, they just go to like a scikit-learn, they just download this and just do this, you know, input, output, classification. They don't know why they're doing this. It's sort of like a Lego data scientist. Say, no, don't be a Lego data scientist. That's not what you're trying to do. You're trying to get an idea first of what kind of algorithm work best with what kind of set of data. Now, at the end of the day, data science is an empirical science. So even though you think, well, it's non-linearly separable, so you should use neural network as opposed to logistic regression, it may turn out that for a particular data set, the noise is so big that the problem is essentially not separable. Okay, so you find that out that, oh, neural network doesn't do anything. In fact, it overfits. So it becomes empirical finding. Okay, but before you do that, you don't just say, throw everything in the kitchen sink. So the second aspect is not just to understand how data scientists work, but to understand the tools, how they work, quote unquote, under the hood. I use the word under the hood a lot. Okay. Third objective is for you to have or be able to code all these things. To be able to code this, again, we use Mathematica as a baseline, but some of you may have come from high school with a lot more Python experience, and you would prefer to do that because you would continue to do that. That's fine as well. But essentially, those are the two languages I think we'll use. We won't go into R, I don't think, except for those two in the back there who might go into biomedical science. You might want to go into R. Okay, that's about it, 2-3 languages. C, C++, no, not quite. Okay, very good. So we are up. Yeah. So the third is to code a complete data analytics pipeline. That's this line here. And finally, from the project thing, you would work in an agile kind of environment. Agile just means like this. In the old days, whenever there's a problem, right? The management would get together, say, this is the problem. Specify the problem, hand it over to maybe system analyst, data engineer, and so forth, and say, okay, you go solve this problem. Okay, this is the specification. You go do solve this, and they go away for 5 months or something. Come back and deliver the result. That's it. Okay, this is called what's called waterfall. It's like water, just boom, everything all at once. Okay, nowadays people don't work like that anymore. Work in what's called agile. Agile is like the user and the programmer, the analyst, the data scientist, the technician. They kind of work together like a small team. And they do successive loop of quote unquote prototyping. So maybe the first loop of prototyping is like a proof of concept. The second would be like a small data set. Third would be maybe a bigger data set and so forth. And they keep refining. So it's kind of like a loop. And to be honest with you, I'm beginning to think teaching should follow agile. The way traditional teaching works is you go from, introduction, topic, and to drill down all the way to the end. But sometimes I'm thinking, actually, you know what? Why don't we just run through from the beginning to the end and then repeat the loop? Because every time you repeat, you actually get more insight. But that's my own that's one idea about education. Sometimes it's sort of like an exercise, okay? But ignore that. So that's what we want to do. I want to review the fact that we have 2 sets of material to rely on. If you look at the syllabus, there's a lot of paper and text that I reference to. If you're really, top-notch student, ideal student, you would look them up, okay? But if you are a little bit lazy, which I'm assuming maybe 80% of you are, you can rely on 2 sources, okay? One is the Xmind, the mind map that, I'm going to use today. And the other one is, of course, the Mathematica notebook. That's all, okay? Now, you notice that there are 2 things. The Mathematica notebook is from my book project. So it's about using Mathematica to do 3 things: interactive visualization, probabilistic modeling, and machine learning, okay? In the mind map, I would not mention much about interactive visualization with Mathematica. So in the mind map that you see today, I'll focus on probabilistic modeling and machine learning, okay? Yeah, I want to tell you about, just to summarize, so you get an idea that, it's not completely haphazard. What have we done in the past 3 or 4 classes, while I was absent and whatnot? So first, we have the first class, which is kind of like introduction to big data analytics, right? What makes the data big? What makes it not? Focus on the why do we do analysis and so forth to get insight. So data analytics is about a set of tools, right, that would turn raw data into some kind of information, right? Information then become insight. That insight is supposed to inform your business, and then you make better decisions. At the end of the day, you get insight because you want to make better decisions. Okay, so everything is kind of like building to that climax. Right, and then we spent, I think, one lecture on basically Mathematica primitives, introduction to Mathematica. So the first thing you need to know is the environment, meaning that there's a notebook for core language. There's Wolfram Alpha, which you can access from the notebook. Today, you can, if you pay some money to OpenAI, you can also access Wolfram Alpha via ChatGPT. Okay, but it's not as precise yet. So if you know what you're doing, this is better. It's a little bit like telling Siri what you want to do with Amazon or something like that. You're relying on that because you're not precise. But if you're precise, you know exactly what you want to buy from Amazon, and you're just checking for prices. It's a lot more efficient to forget Siri and just go to Amazon. It's that kind of thing. Okay. So if you're really imprecise, well, I want some kind of kitchen tools that clean up after I chop some vegetable or something like that. Yeah, you use Siri. Okay. But if you're a professional chef, are you going to do that? No, you actually know exactly what you want. I want to buy this kind of chopping board, this kind of onion slicer, whatever. Immediately go to the shop. Okay, more precise. Same thing here. Okay, same thing here. But I don't know. In the future, maybe things would go the other way around. Maybe instead of this class, the Basai student would start with something like how to use ChatGPT or something, and then go to Wolfram Alpha from that back end. I don't know. That's the future. Okay, but right now I think we might as well be more precise. So we have this environment, we have this Wolfram Alpha, we have the help page, we have the community and so forth. So we show you a little bit about that. And then we spend the boring bits. Remember the boring bits? The boring bit is the primitive. And that primitive is like, if you're going to learn the new language before you become a poet, you have to learn the vocabulary and the grammar. Okay. So, we start with things like, well, what are the basic variable things in Mathematica? You have a single variable, you have a list of variable, you construct it with a table, you have what's called association, which is kind of dictionary in Python, right? Then the data set that I mentioned, and then I make a segue from data set in Mathematica into Python data frame, right? Then the other primitive is, because it's functional programming, you can't tell the computer to do anything. You have to inform the computer what function you want to do, what kind of function you want. If it's a built-in function, you call it. If it's not a built-in function, you have to define the function, then call it. And when you define that function, that may be something completely new mathematics that you invent, or it may just be a series of built-in functions typed together. Okay? So this becomes like a quick step. In one step, I want to do all this. Right. So you have the function, and you have all kind of shortcut to, you learn. And module is a way of hiding variables so that it doesn't affect. So I think we went over that. Okay. Finally, you do this interactivity, which is manipulate and plot. And that's the powerful thing. Okay. So once you master this, then you have the basic tools to do things, to do stuff. Okay. If you want to do advanced stuff, you might have to go to a help page to say, how do you build a neural network? That sort of thing. Yeah. And then, of course, yeah, I said this, Mathematica data set versus Python's pandas. And the good example that I want you to highlight, sorry, this guy here. Yeah. Oops. This analysis of global COVID-19 data, which, by the way, kind of like a project I did with my son, who was then in high school. So it's nothing that complicated. A high school kid could handle. Right. Then last week, just before today, right? Last week, two things happened. One is good old-fashioned data mining. Now, data mining is a terribly boring subject. Okay, as you probably witnessed, it was very boring, it's kind of dry. But you know what? It's useful. Okay, it's useful. You've heard this story about a teenager by shopping online or something like that. Walmart was able to predict that she is pregnant because she keeps buying this basket of products before her father knows or something like that. Well, it's that kind of tradition. It's the idea of market basket. The key concept of data mining is market basket, okay? It's the idea of what do people buy when they come, they go to check out, well, what's in the basket, okay? And you make all kind of association. If you buy milk, you're likely to buy cheese, or you're likely to buy egg, if that sort of thing. So how do they do that? Well, you can think of two things. So this is insight. Let's say you have insight. People who buy bread always buy milk, okay? This is insight. Okay, how do you turn into decision making? Well, if you're nice, you make milk and bread together, right? Because it's convenient. I'm going to buy milk and bread. But you know what supermarkets do? Supermarkets put milk over here and bread over here, so that if you buy milk, you're going to buy bread. In the meantime, you're walking through a whole bunch of stuff and you're picking extra things. Okay, so how you use it, it's up to you. Okay. This is where, you're talking about ethics and whatnot, but I don't care. So why do I have to include it? It's one of those things that it's sort of like almost a standalone module in the entire class, but you have to learn it because when you go into commerce, that's a whole bulk of thing. You work for Lazada, Shopee, Alibaba, and underlying it, there's a big data mining engine that does nothing but market basket analysis. Okay. I even did that for of course, I was running the quant team for SCB. We did that with the SCB Visa card. We know that if you do this kind of spending in the third week, you're likely to spend this category in the fourth week of that sort of thing. It's all by association. Okay. Now, why is it called data mining? I'll give you a little bit of history. Because if you go back 20 years, 30 years before machine learning, neural network, you only have statistical tools. And statistical tools only work with numerical data, right? Like predicting height from the height of your parents, something like that. Now, if your data is egg and milk, how do you do that? Okay, you couldn't do that with, right? So it's kind of, you want to do some kind of statistics of association, but what's the distribution of egg? So you can't really, so you do this kind of heuristic association between egg and milk and bread and beer and all kind of stuff. So this become item. So that was the first time that you used this computer exclusively to study probabilistic thing without turning it into numerical. Okay, so you work with data, and that for the longest time was a branch of science called data mining. Okay, in fact, when I was studying Ph.D., there was a section of the Ph.D. research that did that, called data mining. Nowadays, you go to computer science department, there's no data mining section anymore because everything is done by AI or something like that, right? So it kind of gets subsumed. But anyway, it's so useful, it's ubiquitous, and it's the first quote unquote non-numerical probabilistic data analytics. Okay, so you can say that before there was data analytics, there was nothing but probability statistical inference. And then somebody tried to do something with milk and egg. Okay, and that was data mining. So you can say that data mining was the first data analytics that doesn't smell like statistics. Okay, or smells like statistics but isn't statistics. Okay, so historically it's very important, and that's why it has to be covered. And I think next year I still will cover it, even though technology has gone to large language model and whatnot. You still need to do that. Right. Second thing that happened last week was a special lecture on graph analytics. Now, some of you, right? I think a third of you could not make it because you had that class, right? So we're going to load it. Okay. Now, graph analytics is one of those things where it's also out of sequence. Normally, I would cover graph analytics, so like the last third of the class, because if you think of tabular data as basic, graph data is a little bit more advanced. Okay. So when you listen to it, it may kind of not make that much sense, but you know, the opportunity was there because Dr. Benedek, he's really brilliant. He's Hungarian. And I don't know if I told you this, but Hungarians have tradition about doing graph analysis. All the major breakthrough in graph theory were done by Hungarians. So maybe something nationalistic about it. Anyway, so that was the graph analytics talk. Okay, I'll come back to it. Yeah, remind me, I'll share the presentation in the line group. Okay. I think this morning I share in the line group sort of like a summary of mathematical primitives, so you can use that. Okay, and I think I did that already. The other thing I haven't done, which is remind me to do later. So share the Dr. Benedict's. Okay, fine. So that's where we are today. Okay, one more comment before we go on to today. Like I told you, I've been teaching, well, I've been working with this for a large part of my professional life, and I've been teaching this class for 4 years. And I can guarantee you that the material is not the same from one year to the next. Okay. Part of it has to do with, well, there's some part of it that has to do with the fact that we were teaching this offline during COVID, but a lot of it has to do with the fact that technology changed and the focus of the industry also changed. Okay. So it's not going to be all similar from one year to the next, which is why sometimes if you have time, go back to the YouTube channel, look at the previous year, it's good as well. So the coverage is not going to be the same. But here's the deal. It used to be sort of one course that Basai had, because we don't have a further course in machine learning. So maybe in the first year, I would just throw away all this visualization, go heavy into machine learning. Okay, because that was probably for year one, for 2 years ago, one of the opportunity to do machine learning, because we didn't have another special. So we tried to do the restructuring the curriculum. So there'll be data analytics, there'll be machine learning, and then AI. So these are actually going to be 3 separate courses. Okay, so that allows me, for example, in this year to de-emphasize the machine learning and increase emphasis on interactive visualization, for example. Okay, that's what I think. But at the end of the day, it's going to circulate around this sort of thing. Okay. So today, okay, it's like the first day where I did the introduction, except I'm going to spend entire hour going through the whole scheme from data to analytics, which breaks down to probabilistic modeling and machine learning, the whole, whole shebang, I guess. Okay, the whole story. Okay, the whole story. Pay very good attention to that. Okay, that's one thing I'm going to do. Okay. Second thing I'm going to do is a little bit about data model. Okay, so that data part, I'm going to go a little bit into what's called indexing, and that's separate between why is a data table and why is it a graph. We might skip that. We might come back to it. But the important is, once we've gone through the whole shebang, okay, and that's like the first half of the class today. The second half of the class is where we kind of like have an open discussion, 2.3 and 2.4 combined together. In other words, this is where we get to decide together the focus. Okay, fair? So for example, if I say at the end of the day, there are 3 blocks of things: interactive visualization, okay, probabilistic modeling, okay, and machine learning. These are the 3 blocks. Okay. In the first 1 or 2 years of this course, I decided on the priority. Okay, because basically, some limitation, I guess I had to say, okay, I'm going to spend this much on machine learning, only this much on interactive visualization. The second half of this class is where, in line with your project ambition, we are going to actually decide together how much of a focus on this and this and this. Okay, so keep in mind, there are 3 blocks of things. Okay, each blocks will take you deep into how things work under the hood, and programming exercise, and translating that into project outcome, right? So you have to sort of like, as we go through this whole story, you have to sort of like start plotting in your mind where you would like to spend your project or your learning time. Okay. And so it's not a full democracy, right? I'm not gonna let you guys vote. I'm gonna retain the last say. Okay. But I would like for the first time, I guess this year, as opposed to last year, the priority will take you guys input a little bit. Okay. I think that should be fun. You could do it with a big class, but I think we're small enough. Okay. So that's the game plan today. Anybody question? Okay, let's dig deep, right? So when we dig deep, we go into the mind map. This mind map, by the way, is very, whoops, how come it doesn't come? How come it's not starting? Just like the material coverage from year 1 to, I guess this is the 4th year, it's not the same. This 3 also changed a little bit, okay? Okay, so again, yeah, so we have the introduction, machine learning, statistical method. Again, the interactive visualization is kind of hidden in here because I wish there's something that helps me with the mouse. I can't really see the mouse moving, can you? Okay, right. Okay. So last I think the class 1 we already kind of like went over a little bit of that, right? Data definition, quickly. Anybody? Now I'm gonna have to let's put it this way. Let's say on your final exam, you may have to do that, right? Write a definition of what the oops. Okay. What's the most important thing about data, guys? Come on. First of all, data is a recording, right? If you record what your mom likes for breakfast, is that data? Well, it only pertains to your mom, right? So it's only data if the entire population is mom. Remember I told you that, right? How's your mom entire population? Because what she likes to eat on a Sunday morning is the population of your mom on all the Sundays. Okay? But most of the time, you collect data on your mom, that's not data set, right? So if you collect data on your mom's friend, her friend, their friend, their key group, then this becomes standard recording of a quantifiable or semi-quantitative data record of a sample that represents a bigger population that you're interested in. So data is only important because it allows you to get insight from it, look information from it. Then you make a conclusion about the bigger population. Okay? If you only make conclusion about that data set, by the way, there's a lot of academic paper that does exactly that. It's not all that interesting. It's kind of like backward looking. It's good. It's good. It's good for self-awareness. For example, okay? For example, if I say right now, Thailand is number 5 in carbon emission per capita, right? The population that I would be interested in making conjecture about would be maybe something like, what about other countries? What about Thailand in the future? What about Thailand if we implement this policy? What about next year, blah, blah, blah. But if all I say is Thailand is number 3 in carbon emission per capita, that just gives you awareness. Okay? So this data technically gives you a little bit of insight, but it doesn't allow you to project very much forward, right? But if you have something maybe like Thailand, demographic, per capita, carbon, urbanization trend, then you would be eventually able to make some kind of maybe regression, right? That the reason Thailand uses so much carbon is because we are urban. Whatever. That, by the way, that's not true. Thailand is not that high. Okay. So again, very important. I'm not going to go through this because this has a whole bunch of, obviously. Dimitri, you have to help me make this mouse bigger, but anyway. Okay, so it's a measurement record pertains to specific sample of entities or events, right? That is what? It's whose general population or phenomenon is what we want to get insight on, okay? So you can almost like verbatim repeat this, okay? That's very definition. File format, and this is where we get into things like, okay, now I told you, right? 80% of your life will be spent on tabular, okay? And then you have graph, then you have things like text and so forth. Now, graph, this is the thing that Dr. Benedict was talking about, okay? Anyway, I'll come back to that. The population, the big data, what's the three V of big data, right? Okay, so all this quantitative analytics, I would give this to you so you can play with it. Basically, the exam's answer will be somewhere in here. It's almost like, if I say question 1 is somewhere in the 3rd branch of this thing, and you dig down enough, you get the answer. Okay, so I'll let you play with that. Right. Now, what I want to do is to say, well, there's a difference, right, between statistical method and machine learning. Okay, and I think we talked about it before. Okay, I'll just give you a little bit. I don't know. I didn't cover in the first class, but so historically, if you think about probability or statistical analysis, it's the difference from data analysis to or analytics, modern data analytics, is that it's in terms of data analysis, it only works on numerical data. Remember I told you that's why this thing about basket analysis was not considered probability in statistics. Okay, in fact, if you were a proper statistician, you would really look down on data mining like a hack. So that if I'm a professor in probability or statistics, and my colleague is a professor in data mining, I sort of look down on him like, oh, this is not real science or something like that. But that used to be the way. Anyway, so, and this is where I want you to start thinking. Again, start plotting your life. Okay, what you want to learn from this class. Okay, why is statistical method? Sometimes I say probabilistic model, statistical method, they kind of together, right? One, you start with probability model, the whole thing is statistical method. So, let me ask you this. Statistical method and machine learning, which one is more powerful? Which one is more powerful? You actually you can answer it in 2 ways, and they're both correct, depending on the reason. Okay? Now, this is where I want you to start thinking. Statistical method is less powerful than machine learning because it only applies to small class of problems. Okay? So you think of something that's not powerful because it only does like this. It doesn't do many things. Again, if you talk about a basket of milk, egg, and cheese, statistical method, traditional statistical method doesn't like that. If you talk about text, oh, forget it. Okay? You talk about graph, oh, forget it. Okay? They only do one thing, like distribution of x and multivariate distribution of x1, x2, and x3, x4, and regression like y to x1. Right? So it's a lot less powerful because It's so limited to the kind of problem it works with. Essentially, ultimately, you have to work with X and Y as numbers. Okay? Maybe categorical variables sometimes, but rarely. However, statistical method is also more powerful. The answer to statistical method is also powerful. You're also correct, but you have to get the right reason. It's more correct because it gives more insight. For example, if I tell you that the distribution of stock market return follows log normal, sorry, actually normal. Okay. Stock return follow normal distribution. There's a lot of information in there. You can literally do the quantile, do the probability. It's like in one thing, it says everything. Okay? Whereas if you do things like neural network, maybe it would try to predict average stock price or return, but it's not going to give you something like, well, it's normally distributed between mu and variance sigma squared. It's not going to give you complete, nitty-gritty details. If you talk about statistical problems, statistical method, if you make a conclusion, boy, you get a whole table. Follow multivariate normal distribution with this variant covariance matrix. If you expect the bottom fifth quantile, there's this probability will be cut off at this point. It's, you can get all kinds of insight, powerful, detailed, nitty-gritty. It's like you got, this suit tailor-made, everything. Okay? So you don't have to sort of like put around the problem. You're like, oh, what the probability is the distribution? That's a sort of like imprecise information you work with machine learning. So if I ask you which one is more important on the exam, you can say both. You have to get it right. Okay? Right, that's the reason. Now start thinking about that. Now this is where I actually wish I could use can I? Supposed to draw on a piece of paper, right? I can't just draw on that.
Yeah, piece of paper.
Do you have paper?
I think.
In paper, I can't just draw on that. For everything but paper. Okay, there we go. Now, I'm not teaching you statistical method, but I'm teaching you what you're actually doing when you do statistical method, okay? Right. You guys remember function, right? Function, right? So let's say f of x is equal to 3x squared plus log of 8x. It doesn't matter. It's something stupid, some function, okay? Some function. Now, what it does is that you can always plot this. So this is x and this is function of x. Yeah, this is mathematics, right? So by the way, this is what functional programming is. You tell the computer what x is and it tells you what f of x is. So now in this case, you give just one x. Okay, now watch it. What if I do this? Okay, what if I do this? Okay, if I did this, you get the form and you also get the coefficient, right? You get the form, you get the coefficient. I'm going to break this down. I'm going to say f of x, comma, a, comma, b. Okay, pay attention, is equal to ax squared plus log of bx. Okay. Now, what have I done? I specified that there's an x square function, but the coefficient is left out. There's a log function, but the coefficient is also left out. Okay. Now, technically, when I vary x, I get different value of the function, right? Well, same thing with a and b. If I put in different a, different b, it's also different value, right? So technically, a and x and b, they're all variable, right? Okay, agree with me? Okay. So instead of plotting f versus x, I can also plot f versus x and a and b. Okay, right? You agree with me, right? In functional programming, how would I code this? I would code this as, in Mathematica, it would be something like my function x underscore a underscore b underscore equal to. Okay. So it's actually a function of 3 variables. Now, what happened is, if I ask you this problem, okay, and I specify a and b, and I ask you to plot another problem, I change x, a, and b, you will plot another line, correct? So whereas x is something that varies within the same problem, a and b vary across problems. Okay, so there's a difference. In Mathematica, in coding, it's the same thing, f a x b, right? But in terms of mathematics intuition, you can see that if I taught you this function, I can say exam question number 1, a is equal to 3, b is equal to 7. Plot this one. And I go to question number 2, a is equal to minus 5, b is equal to 57. Plot that function. See, a and b are not constant, right? Right? But within the same context, the same problem. Within the same problem, it's a constant. So I'm going to make a linguistic distinction. A variable that varies within the same problem, the same context, is called a variable. But the input that can change in different contexts, but in the same context is a constant, I will not call it variable, I will call it parameter. Okay? Now, by the way, this is a critical thinking part that I hope stays with you for the rest of your life. The distinction between variable and parameter is a lot more useful than you think. Some of you may actually have startup, but a lot of you, because you have this intellectual capacity, might end up doing management consulting. That's one of the best careers for outside graduates. And the ability to say, this is a variable, this is a parameter, makes a lot of money. It's very important in professional life. I don't really, allow you to be in a position to make a lot of money. You mix variable and parameter, you out of the game. So this insight is very important. Okay. I'm going to move on. What is statistical method? Statistical method. First of all, there's always 2 words, right? Probability and statistics. So I'm going to say, what is probabilistic modeling? Probabilistic model, okay, is nothing more than coming up with this, except this F doesn't represent anything. It represents probability. So I'm going to change the word from F to P. Okay? This is what you do. Probability of X given A and B. Okay? Okay, what? 2 things happen from F generic function, I use P for probability. Okay? So it's a probability of value X. And A and B, because now I'm going to fix it, I'm going to use given. Okay? Sometimes you see this, by the way. Yeah? Sometimes you see this. Yeah? So this here is a variable. This here is parameter. Okay? Okay, remember? Variable. This is the same context. Parameter. A different problem would be different value. It's like, well, okay, let me give you. And this is, I give you this example because what? Well, because it should stay with you the rest of your life. Yeah. So Newton's law, right? Is a function of attraction is proportional to M1 and M2, right? M1 and M2, right? 1 and M2. So it's so like F is equal to G M1 M2 divided by distance. Okay. Forget about distance. Okay. Right now, this is the attraction force between two mass. Okay. So how many variables do I have? Variable, right? But you know what? M2 is U. So that's easy to change. M1 is Earth. That's not really easy to change. So you know what they do? They make this, well, you know, I may write something wrong here, but this is in T Earth. So this function become M given T Earth. Okay, so something like gravity or something like that. See? So gravitational force is a function of how massive you are given this. This is actually a variable. However, because for most of us who live on Earth, it's very rare that we'll do this equation on Mars. We might as well make this a constant, but it's not a real constant. If I did this equation in Mars, that'll be another number. That's the difference between variable and parameter. Yeah, so go back. So here's the deal. This thing here gives value of X, and this is kind of probability that it can take on. Okay, now you take it this probability class, so you know there's discrete, continuous, and all that kind of jazz, right? But the idea here is that this gives some kind of likelihood. Okay, this is how probability model. First, decide on what is the range of X. So it could be discrete, negative, it could be positive and negative. Based on that, select the function that gives you shape. But the function will have three parameters. That's all probability. What's statistical method? Statistical method is that given I have chosen P, I have chosen X, A and B, I have to estimate. How do I estimate it? I collect a bunch of real X and do a histogram. And I select A and B that fit nicely on that histogram. Okay? That's the question. What are the X's that we have? It can be gathered because you collect a set of data so that you can fit the A and B. And it's the A and B that gives insight into nuance. Okay? So, in terms of what we do in data analytics, okay, this is what you do. My inside, the inside I want to know is the likelihood of value X. That's my inside. But I don't have all the X's in here. So I collect 5,000 X. Based on that 5,000 X, based on my assumption what probability function I would use, I draw the histogram, I choose the A and B to make it fit nicely. Clean the fit. Once I make that fit, I make a statement. X in the future has this likelihood, has this shape with parameter A. Okay? That's why the X that you collected, the 5,000 X you collected are there. Because from that, you made assumption P and you estimate A and B. A and B, numerical value of A and B is the inside. And if the inside that doesn't care about this, it's just the 5,000 X, now you can make that conclusion or that kind of statement about the next 5,000 X, next unit. Okay? So that's the name of the game. The name of the game is you want insight about population. Now, you can see right away why I say that this is kind of like a restricted exercise. Because you can't ask that many questions. Okay? You can't ask that many questions. You can only ask questions like probability of value. So in that case, statistical method in a way is limited in that sense. Okay? That now, this is kind of like distributional insight. Where are the X's? If you recall from class 1, there are the other kind of insight that you look for the data. Finding the X, what is the associated Y? Right? That would be regression. Now, regression is done in the same way. Except instead of this function being the where are X's, it would be function of where are Y if I knew the X's. That's why regression equation. Why does the regression equation look like this? Y equal to alpha 0 plus alpha 1 X plus say alpha 2X squared, or something like that. Okay, right? When you did this, the function you showed is constant linear quadratic. And what are the AB? Alpha 0, alpha 1. Okay? How do you get it? Well, this is what you did. You gather 5,000 X, and therefore you have corresponding 5,000 Y. And then you choose alpha 0, alpha 1, alpha 2 in such a way that they match really nicely. So it's not one histogram, it's one histogram per value X. And that's why the regression picture often looks like this. Right? So you don't have just one distribution. You have one distribution per value X. But think about it, it's exactly the same exercise. But instead of saying, I get 5,000 X, so I can get the likelihood of the next 10,000 X. I would say, I gathered 5,000 X and 5,000 Y, so that if I knew the next 10,000 X, I can guess the next 10,000 Y. Same problem. So same style, right? Same style. That is what the statistical method is. So the limitation is that, again, you have to work with something that is numerical, ultimately. In this case, Y can be categorical, but X is always numerical. Okay, so that's the limitation. And the hard part about this is that you have to choose P or F wisely. Okay, that's why you get Ph.D. in this. Okay, teaches you how to choose wisely. Okay, now, why is this more powerful than a machine learning. But it's less powerful because it doesn't answer many things. It's probability. It's the value. But it's more powerful because once I got this shape, right, I can scrutinize. I can do the slope, I can do the integration, I can do all kinds of stuff. That's what I mean by more detail. That's it. So that's the name of the game. So, yeah, in the back of your mind, what do you do with life? By life, does your project going to work with something like data, where you are going to tell yourself, you know, I look at this data and I look at this histogram and I play with it enough, I can choose P wisely. My job then will be to estimate A and B. Or I can choose regression equation wisely, and my job will be to estimate alpha 0, alpha 1, alpha 2. All this time, I should have changed the screen. Never mind. Well, yeah. Right, but yeah. Okay, next time I have to sit next to you. Huh? No, that's not a drawing.
A drawing.
I want a drawing. I want the drawing to appear on.
Oh, this. Okay.
Sorry, I'm still learning how to switch back and forth. Okay. Okay, there it is. There it is. Choose P wisely. Estimate A and B based on 5,000 X. Choose this equation wisely. Estimate alpha 0, alpha 1, alpha 2 based on collection of 5,000 X and Y. Once you got that, you're happy, you say, give me the X, I give you the Y. Okay, that's what. Whereas here, you just say, what's the likelihood of the next X? So this thing here basically is the name of the game. Okay? Statistical method is based on breaking down your question into the form of what function gives the best estimate of probability. It will be probability of X itself or probability of Y given X. There's two cases. That's it. Where are the X's? Or if I knew X, what would the Y be? And this is so those are the two kind of questions that you can ask, but you always ask relative to X that is numerical, right? And in answering, you are required by law, I guess, to specify first what the P is. Okay? Now this is where you go to, I don't know if I did this in the first class, where you go to the Wikipedia page, look at the bottom. Have I done that for you guys? No? Okay, I teach so many classes, I'm like forget what I covered. Okay. How do we do this? Now this will be, I stop share here. I come over here and I start Wikipedia page. Go to Wikipedia page and switch that. You go to Wikipedia. Type in something like normal distribution. Now, before you go, look at this. Yeah, look at X. Look at X, right? X can be continuous. It can be discrete. Yeah, continuous or discrete. X can be positive only, or minus infinity to plus infinity, or X can be bounded with two values, like 0. So they're actually How many cases? Okay. So discrete, continuous. So when I say choose probability wisely, the first thing you have to say is choose the one that does the job. X is discrete. I'm going to fit it with continuous probability. I'll be wrong. Okay? Now, there's some cases where you have to do that. Okay. Normal distribution. I don't care about normal distribution. What I care about is the bottom of the page. I don't care at all about probabilities is normal distribution. I just want to go to the bottom of the page. There. This is the catalog, guys. Okay. Your X can be continuous or discrete. If it's discrete, it could be finite, for example, 0, 1, 2, 3, but not up to infinity. It could be infinite, that goes up to infinity. If it's continuous, it could be bounded, say between 0 and 1. It could be semi-bounded, 0 to infinity. Or it could be unbounded, minus infinity to plus infinity. Okay? So when you look at the data, you have to decide is discrete or not, the range. A lot of times it's obvious to you. For example, a height of human being cannot be negative. Right? So you definitely can't have this. Okay? Now, here's what I mean. Each of those points is a name of the function. So when I say statistical method means choosing the P wisely, that means once you get the data X, you decide what world you operate in. 1, 2, 3, 4, 5. There are 5 world operators. Okay? So this is how your project will look like. Okay? For this kind of data set, right? Now this is not regression. This is just where the distribution. Which world you live in? And from this world, you choose the one that is best. Once you click on this, let's say you chose this. You go to that page, there will be a list of parameters. You get the data, you pick the parameter, and the data. That's it. This is how statistical method works. Data analytics with statistical method. Right? Now, this is only for distribution. For regression, there's another page for it. But that's the style of thing you're going to be working. Now, if you happen to click on this page, which is normal, well, you're already here, this page. You will see that this normal distribution is unbounded, goes to minus infinity, plus infinity. The shape depends on 2 parameters, mu, sigma. Get to 5,000x, get the mu and sigma that makes this thing fit the histogram effect. And you're done. Once you're done, what kind of insight can you say? The only thing you can say is, what's the likelihood of the next x? But you can ask a lot more because this is a mathematical function. You can precisely tell you which probability, down to the 10th decimal digit. That's what I mean by a lot more detail. When you work with neural network or machine learning in general, you don't get that kind of precise estimate. Very powerful. Yeah. So ponder with that. More significant, more powerful, less powerful. But that's exactly the name of the game. That's all you do. Okay? But it's powerful. For example, let's take a step further. Let's say you study statistical methods so well. Okay? You know how to do this kind of distribution, By the way, this distribution is only 1x. If you're gonna do multivariate distribution, there's a whole bunch more to say. Fine. But let's think in terms of application. Right now, it sounds so boring. Wait, I can't believe that the last 300 years of statisticians, they've been just working on this. Well, first of all, without computer, that's basically all they can do. Because this is driven by mathematics. Okay? A lot of things we do today, it's not that people 200 years ago didn't have the mind to do it. They didn't have the computer. Okay? So this, in theory, could be done with your pen and pencil. Okay? So that's why for the last 300 years or so, data analytics is built around probability. Because it's built around mathematics. Because people for the last 300 years have had pen and pencil. But they haven't had computer. Okay? So that's one good reason. Okay? But it's so powerful that it applies for a lot of problems. You work. Let me take a step further. Well, I used to work at the Bank of Thailand. Somewhere in the Bank of Thailand, there's a gigantic 500 variable models that describe how Thailand economy responds to certain factors. Okay? Right now, in theory, okay, you can call the Bank of Thailand and say, what would happen if the oil price goes from this much per barrel to that much per barrel? And go through this regression equation, and they will tell you, oh, you know what? In the third quarter of this year, inflation will go up by 0.45. What did I just do? I get the oil price, and I ask for inflation 3 quarters down the line. So the whole thing about econometric modeling is about how economic factors relate to each other via regression. Okay? It sounds really primitive, but believe me, it's not a primitive regression equation. It's very sophisticated. But at the end of the day, conceivably, that's what it does. How do they know this? Because they've gathered 1,000 or 5,000 X. In this case, the X represents maybe quarterly economic factor. They've done this for 10 years, 20 years. So that population, that sample is past. That population is the past all the way to the future. It's like that problem of predicting what your mom likes to eat on the weekend. Bank of Thailand doesn't care about GDP of Laos. So it's only care about GDP and inflation of Thailand. So the population is Thailand past, present, future. But it's so complicated. It's a big system, right? So you take army of and Thailand. Okay? So it's not trivial, it's not boring, but that is the style of data analytics with probability of statistical method. Okay? Your job is to ask yourself, is this my cup of tea? Is this the style of analysis I want to play for my project? Okay, so this here, yeah, let's make a break. So this is the block. And this is the block. Now, before I go to the break, I'll just show you quickly here in the mind map. Again, the mind map will be bequeathed to you so you can look at it. Okay. Now, let me run over quickly what's in the statistical method. Okay. So this. So probability model, that's the first part. So probability. Now, I told you in a quick shot, right? Somebody has already worked out all the probability functions. Your job is to choose the one that works best, right? But professional academics, obviously, this was not given to them. That probability distribution you see the Wikipedia page, that wasn't come up overnight. It was 300 years worth of mathematicians. Okay? So That's these guys. So they develop this. Even to this day, they come up with new functions that fit better. There's a reason why that list that you saw in Wikipedia, that's not complete. It's not complete because there are more. It's not complete because people will keep inventing. And there are reasons why they have to invent, because they're new phenomena. Okay? So if you're talking about invention, innovation, you can think of statistician or probability theoretician as an inventor. You know, my career, I invented 5 F. How many invent? Oh, I invented only 1 F, but this F really is useful. Okay? So that's kind of invention for the last 300 years. Mathematicians come up with that. And those that you saw at the bottom of the Wikipedia page are the most useful. Now, at some point, we'll go into individual distribution. And I will tell you, mark my word, from my estimation, from my work experience, I can tell you that you don't need all 50, 60 of them. You need about 10. Yeah? If you learn 10 of them, you're good. Everything else is so esoteric that you don't need to learn. If you're going to be in a job that requires this kind of really weird esoteric distribution, they'll teach you. Nobody would expect you to know this distribution on network topology if you haven't worked in network topology. Yeah. So when you go there, they teach you. But as an undergraduate program, as a data analytics student, there are about 10 of them. That's kind of nice, right? It's kind of like, oh, I don't have to learn about 50, only about 10. And in fact, I don't know 50 of them. Okay, so 10 would be good. So basically, probability model is about coming up with all that. And inferential statistics, when it comes down to it, is to say, you assume the F, you assume the P, estimate the output. Everything else is deep down, detailed. So just to go a little bit. Oops. How do I go to the left? I'm not going to go into detail, but again, let me go to the probability. If you decide that this is the direction you want to go to, we'll dig deep. But essentially, you need to know foundation concept, unique variate distribution, that's the distribution of X, this 1X, multivariate distribution, that's a distribution of many X's. Sampling distribution, this is like saying, well, in order to get what happens to all the X's given 5,000 X, what is the link? Right? If I have this 5,000 X, how do I estimate what happens to all of it? If I have this 50 X instead of 5,000, how do I estimate my estimate? Okay. Long story short, the bigger the sample, the more obvious. It's obvious, right? If the population of human being is 6 billion and your sample is 5 versus your sample is 5,000, 5,000 is probably better than 5. 5 million is better than 5. That's it. Yeah. But that has to do with sampling distribution. Okay. And then in terms of inferential, certainly that's sort of like the application side. You assume the F, what can you do? Well, certainly you can estimate, like the alphas, right? Analysis of variance. This is kind of something that's also useful. Again, we will go into this if that's the sort of thing you want to go. Yeah. Analysis of variance is kind of like, well, actually, it's very good too. Those of you who go into health domain, a lot of medical statistics is about that. Why? Because they want to say that, okay, I have 5 groups of patients. This group received drug A. This group received drug A, but it was told it was drug B. This one was given drug A that's actually placebo. This one is given drug A and also, all kinds of stuff. And they try to say, okay, after I've given this, they take some kind of blood value. or maybe longevity, how long this group live. Okay? Do different treatments affect the outcome? So this is kind of comparing groups of treatment. So analysis of variance, ultimately it comes down to this parameter investigation, alpha. But the form of analysis is to say, yes, it does matter. Group A is different from group B. Group B is different from group C. Or maybe group A and group B are not different, but definitely among the three groups, somebody is different. Okay, so medical research, a large part of it would read like this. Goodness of fit test, this is like checking your homework for statistician. So remember I told you your job is to choose the F wisely and estimate the alpha and the beta. Well, you send that to your teacher, and your teacher grade you whether or not you really did a good job. There's a whole bunch of statistical tools that evaluates the result of statistics. So it's kind of like meta statistics, right? First you find the statistic of the distribution, and then you ask, is that good using statistics? So this falls under what's called goodness of fit test. It's also very good. Okay? Regression analysis, okay? That's when you make one test. This is the one that is closest in spirit. These two. To machine learning, I'll tell you one later. Okay? So maybe these two. Well, I can't say. But definitely this one has a very clear analog to what happened in machine learning. Okay? I can put in the bracket supervised learning. Okay? So machine learning, we haven't talked about it yet. There are many paradigms. But one paradigm of machine learning is called supervised learning, and that's almost a carbon copy of what happens there, except done differently. Okay? Finally, now this is the biggest regret I have. Bayesian statistics or Bayesian method is one of the most powerful way of working with statistical method. However, it's very hard in school. And really, I think it's so, let's say it's important, but I don't have the luxury of covering that in this class. Okay? But if you were to ask me, if I can just snap my finger and create a reinforced in statistics on both sides, I would say we should have one just for basic. Okay? It's that good. It's that good. But anyway, nowadays, given that most of the machine learning algorithm work similar way in experience. So maybe you can say that, well, it's okay, you're not missing much if you haven't done basic. Okay, but for the longest time, I really regret that undergraduate don't cover this enough. Anyway, so that's the thing. So let's take a 5-minute break. Come back. I kind of like dig, but maybe deeper because statistics I can just do do hand grading and stuff like that. Machine learning, I'm going to go to each branch. Right? So I'm going to do that after the break. Okay. When we did that, I want you guys to feel sort of give me feedback of where you want to focus your project. Yeah? So start thinking. Okay.